Solving linear inequalities, the basics. All the rules for solving linear inequalities. Now, an inequality is a less than or equal to, a greater than or a greater than or equal to. So all the rules for solving those are the same as solving linear equations. So if I do something when I'm solving this and you wonder why I did it, go watch my solving linear equations videos, all right? Except there's one thing that's different. When you multiply or divide both sides, that is huge, both sides of the inequality by a negative number. Not if there's already a negative number that you're distributing in there. I'm saying if you multiply both sides by a negative number or divide both sides by a negative number, you must change the direction of the inequality. So if it's a less than, it becomes a greater than. It doesn't matter if it has the equal to on it or not. That stays or doesn't stay, okay? So if you need help understanding, again, why it's taken, watch my Solving Linear Equations series of videos. If you need help writing in interval notation, be sure to watch my video, Interval Notation, the Basics. All right, solve each inequality. Draw a number line. Put your final answer in interval notation. Okay, so solve the inequality. That's going to be the x or y or z or w, whatever is greater than 6 or less than 0 or greater than or equal to 1/2, whatever it happens to be. Then the number line, we're going to draw it on that, and then we're going to put your final answer in interval notation. Your teacher, your instructor, your class, if you're not in mine, may or may not do all these things. In fact, in my class, at different levels of algebra, I ask you to go to different levels of this. Solve the inequality. Solve the inequality, put it in interval notation, whatever, okay? So just be sure you know what your teacher requires of you. But I want to go over all of it so that you've seen all of it here, all right? So here, I need to solve this. Well, how do I undo this minus 3 with the x? I'm going to add 3 to both sides. That cancels. It goes x is less than or equal to. We didn't multiply or divide by a negative, so this direction doesn't change here, okay? So then this is going to be 9. X is less than or equal to 9. This is the inequality right here, okay? The inequality. Solve the inequality. In fact, I'll do solve the inequality in red. I'll do the number line in blue, and then I'll put it in interval notation in this green on all of them on this page to color code it for you. Hopefully that will help some, all right? So then on my number line here, draw my arrows here, and I'll draw the number 9. Less than 9 is to the left. Shade that arrow. Anytime I shade that arrow, I put negative infinity there. And then this gets a bracket because of this equals. That's why I get a bracket. Not because it's less than, not because it's 9, not because it's positive, because of the equals. So then my interval notation then is going to look something like this. It's going to be from negative infinity, comma 9. You have to go in order from smallest to largest. So here's where you started shading. Here's where you ended your shading. All right, put a comma between them. Infinity and negative infinity always get a parenthesis, and then here the bracket goes on the 9, okay? So this is going to be bracket. So then let's do the one beside it. X plus 5 is greater than 7. How do I get rid of the plus 5? Subtract 5. So then x is greater than 2. Now look, that's the most efficient way to solve this, is to move the one term here. And the thing by itself, the 7 said, hey, move the 5. Here's what I'm going to do. I'm going to get the variable on the left-hand side because I think it is easier to understand, like less than, greater than, when the x or the y or the w or whatever's on the left. Notice that you did not hear me say that you must put your variable on the left. If you're told you must do that mathematically, that is incorrect. That's not a must in math, okay? But it might be a requirement for your class. If your teacher says do it, then do what your teacher says. You're in their class. Okay? But for math, it's not a requirement. It can go on either side. I'm going to put my x's or variables on the left because it just makes it easier. When I say x is greater than 2, I know that, hey, that means to the right. And if you put your variable on the left, this points to where you shade on your number line every time. So that's my inequality. Let's look at my number line. So my number line here, I got the number 2, and greater than 2 is to the right. So I'm going to shade out here, shade this arrow, darken it in. And if I shade the right arrow, that's infinity. What goes around 2 this time? Well, a parenthesis. A parenthesis goes around it if there's no equals. There's no equals here, so you use a parenthesis. So then the interval notation, you started at what? You started at the number 2, comma, and you went all the way out to infinity. What does infinity and negative infinity always get? Parenthesis. And the 2 here gets a parenthesis because that's what you get there, right? That's what you had up there. So 2, comma, infinity, both of them with parentheses. All right? So 2y is less than or equal to 11. 2y is less than or equal to 11. Want to get y by itself? divide. Divide both sides by 2. Y is less than or equal to 11 halves. It's okay that it's a fraction. If you wanted to put 5.5 or 5.5, I guess you could, but 11 halves is a wonderful number. You need to know it's 5.5. You need to know it's between 5 and 6. Okay, but that's your inequality. It's solved. So now when I do my number line, right, and I didn't say this before, but a lot of y'all want to put 0 there because you told you got to put 0 in the middle. It's a line that goes on forever. It's infinite. There is no middle. There's a middle to what I drew. Okay, and then some of y'all are taught, like on this 9, you had to go 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. Don't do that, because if you have 467, I'll be opening Christmas presents. You'll be at 420, 421. Okay, trying to do it. Don't do that. All right. So what number do I care about here? I only care about 11 halves. Don't worry about putting something else there. Don't worry about it. I addressed this in my interval notation video. So go watch it. All right. But there's no need to put anything there except what you're concerned with. And I'm concerned with 11 halves. Less than that is going to be to the left. And that's going to be negative infinity. And this is going to be a bracket again. So then on my interval notation, I start at negative infinity, comma, 11 halves. Negative infinity gets parentheses, 11 halves or parentheses, and that gets a bracket because it is got the equals here. It has the equals, so it is a bracket. Negative 4w greater than or equal to 28. So how do I do this? I'm going to divide both sides by negative 4. So then that divides out. W, that divides out, by the way, just like the 2 does. It doesn't cancel. It divides out. W is less than or equal to. Why did I change the direction here? Because I divided both sides by a negative number. This and this is why I did that. So then 28 divided by negative 4 is negative 7. So W is now less than negative 7. And for all of you screaming at the computer screen because you Googled the definition of cancel and it says that cancels, that's because math teachers lied to Merriam-Webster long enough they put it in their dictionary. Okay, but new math books don't say that. 30-year-old math books say they canceled. Your teacher was probably taught by a teacher who had a book that said cancel, or they had it themselves. Books said cancel when I was in school, but it's not what it is. All right, so I'm not going to fight that battle too hard because I know everybody says it because it was taught for so long incorrectly. Negative 7. So then less than or equal to negative 7 is out here to the left, and that's going to be negative infinity with a bracket. So we got a bunch of these with brackets going to the negative infinity, don't we? So third one here out of 4. Negative infinity, comma, negative 7. Negative 7 is a bracket. Negative infinity, always a parenthesis. So there's your interval notation. Let's just wait a minute. There's your interval notation. All right, here's some more. And I'm going to change my color schemes up just to use some more colors here. But I'll try to change it up with each step that I do, I change it. So here, I'm going to do what? Divide both sides by negative 5. And if I divide both sides by a negative, x is now greater than a positive 10. My answer is positive. That doesn't have anything to do with my turning my inequality around or changing the direction of it. It's the division of negative 5 on both sides. That's why that changed. So that inequality is now saved, or solved, I'm sorry, not saved, solved. And so then I want to come over here and put this on the line and see 10 is what I care about. Greater than 10 is to the right. Shade that arrow. And that's infinity. And 10 gets a what? Parenthesis here. So we have, for our interval notation, we have parentheses 10, comma, infinity with a parenthesis. Okay? And again, let me reiterate, if you don't know why divided by negative 5, or if you don't know why I use a parenthesis on the 10, this interval notation video, this step here is the solving linear equation series of videos. It just tells you why I do each one of those steps. All right? So let's keep moving here. What do I do first on this one? I'm going to add 3 to both sides because I undo addition or subtraction first. 2m greater than or equal to 14, and then I divide both sides by 2. M is compared to 7. Do I change my greater than or equal to? No, because I divided by a positive number there. Do not change it. M is greater than or equal to 7. So that one took a little bit more work. But I still now do what? Come to a number line. And I care about the number 7. And greater than or equal to is to the right. And again, also, if you put your variable on the left, it points to where you shade. That points points right. So this is infinity. Variables on the left. And then a bracket around 7. So it's going to be, for my interval notation, what? Bracket 7, comma, infinity with a parenthesis. And so then y over 4 is greater than 3. So what do I need to do? I need to get rid of the 4, and it's divided by 4. So what's the opposite of dividing by 4? Multiplying by 4. So I'm going to multiply both sides by 4. This is over 1. That divides out. Doesn't cancel, divides out. So y is greater than, and I multiply both sides by a positive. Don't change the greater than. 3 times 4 is what? 12. So that's y is greater than 12. So there's my inequality. On my number line, I care about one number, 12. Which way is greater than? To the right. Shade the arrow. What does the arrow represent if it's to the right? Infinity. And this is a parenthesis because there's no equals. So then my interval notation looks like parentheses, 12, comma, infinity, parentheses. Or parenthesis. It's singular, I suppose. (3x) divided by 7 less than or equal to 6. Again, I know that many teachers will teach this a little differently, but I always do fractions the same way. I have a fraction. I need my LCD, and I could have written that over here. And in fact, let me go back and write that down. It was divided by 4, but the LCD there was 4. Okay, so I multiplied everything by the LCD on both sides. So I'm going to do the same thing here. What is my LCD? 7. I'm going to multiply both sides by 7 to start with. I always do that. I'm not going to do 7/3. You can do that if you want to, but that's changing the way I work it. And when a student is learning something, I think the student, you need to see it the same way every time. And then when you begin to go, oh, you know what? I'm just multiplying by 7 and then dividing by 3. Why don't I do it at once? Then now you figured it out. You've seen it. You won't forget it. If I, as the teacher, go straight to that and say, oh, when you have this case, you'll try to use it everywhere because it's easier than something else, and you'll misuse it because for 30 years I've seen it misused whether tutoring or teaching. Okay? Every single semester. Not one semester in my 22 years of teaching have I ever had a student not try to cross multiply wrong. So that's basically what that would be if you did the flip it thing. All right? So I just multiply by the LCD and then go from there. So the 7s divide out. They become 1s, and I'm left with 3x is less than or equal to 42. I did not multiply by a negative. Don't change that less than or equal to. Then I'm going to divide both sides by what? My coefficient, which is 3. And then x still less than or equal to 42 divided by 3 is 14. Then I'm going to draw my number line. And I care about one number on my number line. What is it? 14. Which way is less than or equal to? To the left. And then this, if you'll notice, sometimes I draw 2 circles beside each other. And that one's actually kind of bad because it looked like the Olympic rings. So I'm going to connect it. Still not a great infinity, but I'm going to connect it. And then what goes around 14 is going to be a bracket. So then negative infinity, comma, 14, bracket on 14, and parentheses on negative infinity. Ooh, and I didn't change colors there, so let me fix that. I didn't write it wrong. I just didn't change color. I've been changing colors from number line to interval notation the whole time, so let me go do that. Negative, and that was actually written relatively neatly. For me, anyway. I know you can feel sorry for me for how bad my writing is. All right, so let's see what we have next. Okay? Negative 5p plus 1 is less than 33, so I'm going to solve. I'm going to subtract 1 from both sides here. Negative 5p is less than 32. Divide both sides by negative 5. So then p is greater than negative 32 fifths. So that's the inequality. Then we're going to come through and do the number line. On the number line, I care about what? Negative 32 fifths. Greater than is to the right. And I changed it from less than to greater than because I divided both sides by negative 5. Right? Then I'm going to shade the arrow. That's infinity. And a parenthesis because there's no equals. So we're going to do parentheses, negative 32 fifths, comma, infinity, with a parenthesis. And I didn't change colors for my interval notation again. But I'm trying to put each part in a different color. That way you can kind of see which one is which. All right. So then now they get a little more complicated. 5x minus 3 greater than or equal to 4x plus 17. The same way we'd solve it. I'm going to move my x's to the left. I'm even going to ignore my rule I teach you in linear inequalities of saying, hey, If it's one less, move it. But this one happens to be one less. But I'm going to move my 4x, and I want you to get where you do this on the same step, and I'm going to keep doing it separately. I want you to say, oh, add 3 at the same time, right? That's what I want you to end up doing. But right now, I'm not going to do that. So that cancels. We get x minus 3 greater than or equal to 17. We're going to add 3 to both sides, and we get x is greater than or equal to 20. And that solves my inequality. On my number line, I care about 20. Greater than or equal to is to the right. And then this is infinity, and we have bracket. And then we have, for my interval notation, what? Bracket 20, comma, infinity, parenthesis. And hopefully the interval notation is coming into focus here as far as how it is to write that, especially if your teacher requires that. Okay? And I've already said in some of my classes, many of my algebra classes I require. There's a couple I teach maybe where I don't sometimes. All right. So here, the next one, I'm going to move my 5x. I'm going to subtract it from both sides. So then that's going to be 2x minus 20 less than or equal to negative 8. I'm going to add 20 to both sides. To get rid of that, that's going to be 2x is less than or equal to 12. Divide both sides by 2. And again, I leave less than or equal to alone because I did not multiply or divide by a negative at any point there in any of those steps. So x is less than or equal to 6 is my final inequality there. And that one took several steps. Okay? So then over here, I mean, anything that happens in equations can happen here as far as how long it could be. It could be a long, long, long with parentheses and distribution and order of operations everywhere and powers and all kind of stuff. Okay? So less than or equal to 6 is to the left. And then shade my arrow. My arrow represents negative infinity, and 6 is a bracket. And so then my interval notation is going to be negative infinity, comma, 6. It's going to be a bracket and parentheses. And that is that one. So 3y plus 10 greater than 4y plus 23. Again, I know the 3y is one less, and that's how I do the equations, but I'm going to do this one and get my y on the left. You don't have to do it. It just, to me, it makes it easier. So I'm going to cost myself an extra step on this problem. So then negative y plus 10 greater than 23. And then I'm going to subtract 10. And I get negative y is greater than, not negative, positive 13. 23 minus 10 is 13. Then I divide both sides by negative 1 or multiply by negative 1, however you do it. Y is less than. Why did I change that to less than? Because I divided both sides by a negative. Okay? Not because my answer is negative, not because it's less than, not because it's y, because I divided both sides by a negative. So there's your final inequality solution. Okay? So then on my number line, I care about negative 13, less than is to the left. And then this is infinity, negative with a parenthesis. And then negative infinity, comma, negative 13, parentheses. So there's your interval notation for that one. And this is your solving linear inequalities, the basics. If you need some help with some bigger inequalities, I have one, solving linear inequalities more. So solving the linear inequalities more if you need some more help with this for some more advanced inequalities.